the depth of that point from the surface. Rho is the density of the fluid. So pressure at a point, P equal to H rho G. Don't forget that. Transmission of pressure in fluid, Pascal's law. We have a number of applications where pressure exerted in a fluid is transmitted through the fluid. Now, have you ever come across an example where pressure exerted at one part of a fluid is transmitted right through the body of the liquid? Now, Pascal's law is a statement about how an increase in pressure at one point within a liquid or a fluid is transmitted within the liquid to other parts. Pascal's law states that an increase in pressure at any point in a fluid is transmitted without change to all points within the fluid. Now, I'm sure you know that the brake of your car, isn't it a hydraulic brake? You use a brake fluid in your car. Have you ever noticed that? When you pump on your brake, what happens is you are applying a pressure on the brake fluid that is connected to the brake that goes through a tube. So when you press on the brake, the pressure inside the brake fluid increases at the point where the brake is pressed. There is an increase in pressure at one part of that fluid. That increase in pressure is transmitted without change right through the fluid until it reaches the brake drums where that increase in pressure is felt, where it executes that braking process. Is that right? So in the hydraulic brakes that you use in your car, we use Pascal's law. An increase in pressure at one point within the fluid is transmitted without change throughout the fluid to other points. Now, a hydraulic lift that lifts your car for repairs uses the same principle. Well, the figure shows a weight W placed on the surface of a fluid inside a container. Now, when you place a weight on the surface of a fluid, that will cause an increase in pressure at points that are close to that weight. Is that right? The weight causes an increase in pressure at points immediately in contact with the weight. According to Pascal's law, this increase in pressure is transmitted to all other points within the fluid. An increase in pressure at points immediately in contact with that weight is transmitted so that the same increase in pressure is felt at point A and at point B. An increase in pressure at one point within a fluid is transmitted without change to all other points within the liquid. So the same increase in pressure will be felt at points A and B. An application of this principle is found in the hydraulic lift. Let's take a look at how a hydraulic lift is made and what is the principle of action of a hydraulic lift. Well, a hydraulic lift really consists of a simple phenomenon. It's a container that contains a fluid. Now, the container has a narrow limb and a broad limb. Each of these is closed by a piston. The piston or plunger, this is the piston that is on the narrow limb. It's also called the plunger, where you can apply a force. Now, this piston has an area A1 on which you can apply a force. And on the other limb, you have a platform on which a load is placed. You want to raise that load. The area of that piston here is A2. So once again, there are two limbs for the container. One is a narrow limb and the other is a broad limb. In the narrow limb, you have a piston which has an area A1. You can also call it a plunger. You can apply a force on it. So this has an area A1, and the platform on the other side has an area A2. Alright. When you apply a force on the plunger, when a force F1 is applied on the piston, it causes an increase in pressure P equal to F1 over A1. Is that right? You apply a force F1 distributed over an area A1. So what is the increase in pressure that force will cause? That force causes an increase in pressure P equal to F1 divided by A1. And that increase in pressure is felt all over these points which are directly in contact with this piston. Well, according to Pascal's law, an increase in pressure at one part of a fluid will be transmitted without change to all other parts of the fluid. So that means an increase in pressure here will be experienced by an increase in pressure on the other side as well. This means that an increase in pressure on the platform of area A2 is also P. When there is an increase in pressure P near the plunger, there will be a corresponding and same increase in pressure near the platform. Well, if there is an increase in pressure near the platform, what is the force that will then push the platform up? This increase in pressure causes an increase in thrust on the platform. How much is the increase in thrust? It will be the pressure multiplied by this area, which is A2. So F2 is a measure of the thrust on the platform of area A2. That is the pressure on it multiplied by the area A2. This is at the increase in pressure on it multiplied by the area A2. And that gives the increase in thrust on that platform. Now that will be, if you now replace this P, remember P equal to F1 over A1. So if you replace this P by F1 over A1, we get F2 equal to F1 over A1 times A2. And we can rearrange it to read like this. F2 equal to F1 times A2 over A1. Now what does that mean? You know by looking at it, A2 is much greater than A1. Suppose the area A2 is 5 times the area A1. Then A2 by A1 will be 5. Therefore, the increase in force, the increase in thrust at the platform will be 5 times the force you applied on the plunger. What it tells you is that you can actually apply 5 times the amount of force on this side by applying a small force at the plunger. If you apply a force of 10 Newton at the plunger, at the platform you can lift a weight of 10 times 5, 50 Newton if A2 over A1 is 5. So the amount by which the force gets multiplied is determined by the ratio of the areas. By increasing this ratio, we can increase the amount of force that can be lifted. Well, what does it mean? Does it mean that we can manufacture force just like that? Can we just get force free? Well, if you notice one thing, in order to lift a greater force on the right side, you apply a small force on the left. But this small force has to move through a very large distance in order that you lift this large weight through a very small distance. When you gain in force, you lose in distance. You see, energy cannot be created. The maximum energy output you can have here is the energy input here. Energy cannot be created. You know that work done is a measure of the energy used. So what is the input work done? The input work done is the input force multiplied by the distance moved by the piston. The output work will be the output force multiplied by the distance it will move. When you multiply the output force, the output distance will be very small. So that is one thing you need to remember here. Conservation of energy is a very important principle. Nobody can break it. Okay. So as A2 over A1 is greater than 1, the output force F2 is much larger than the input force F1. Okay, let's now talk about